Okej. Skit i bilden då. När vi engagerar oss i att öppna dörren mellan forskningen och omvärlden, det är då som vi tar forskningen från att enbart jobba med kunskaps- och kompetensutveckling till att också göra nytta i samhället. Och vice versa, när vi öppnar dörren så att vi får människor ute i näringslivet och i det offentliga att faktiskt komma, som Morgan bjöd in till när det gäller utbildningarna, och som Marianit har bjudit in till, och som Welf och andra forskare bjuder in till, och säger: vad är viktigt för er att utveckla? Ja, då skapar vi ytterligare, tror jag, värde hos er som är forskare. Ni som är forskare här i rummet, räck upp en hand om ni håller med mig. Ja, jag ser några som håller med. Att det finns en nytta i att det finns ett kravställande från omvärlden, så att man förstår att det man gör landar i någonting som är behovsformulerat, så att säga. Och det är ju en grundfråga i det som vi gör från IEC:s sida. Det är ju ett av projektets viktigaste uppdrag, att just på något sätt åstadkomma bryggan och bidra till samspelet där. Och jag tror att en av de mest spännande sakerna inom det området just nu är det som Welf Löwe, som är vår forskningsledare här på IEC. Vi ska rigga ljud på dig också. Den andra myggan är... Ja, du har den där. Bra. Kommer att berätta om här. Därför att det här handlar verkligen om en stor satsning här, där alla möjliga sektorer och forskningsområden samlas. Så over to you.
Hello. Hörs jag? Very good. Yes, this is an initiative that we are just about to start, and it's called Big Data at LNU, or it's called different names, different occasions, but it's an initiative of awfully many researchers at our university, and we would like to do research, applied research most of all, around the topic of big data. And since this is a university presentation, I start with a definition, since everybody loves definitions. So big data is, well, analyzing big sets or streams to gain knowledge about technical, society, scientific or economical phenomena. And big usually means beyond the capacity of humans or commonly used hardware, and we speak of a few terabytes or even petabytes. To bring this down to something that is more tangible, this machine here, it's 3 years old. This has 512 gigabytes of disk space. So that's half a terabyte. On that half of a terabyte, I could actually have information that provides me with 1 year of music, or it provides me with 20 days of videos. I could save 150,000 photos on it, or 10 days of Hollywood movies. So that's what this little machine can hold. If you look at the data produced every day, then we can observe that there's a quarter of a terabyte of Twitter data, Twitter messages that are produced each day. So in 2 days, my machine wouldn't be sufficient any longer. I would have to buy a new one, and in the next 2 days, yet another one. There are incredible 100 terabytes of data uploaded daily to Facebook. That's factor 400 of our Twitter messages. Okay, so then not even minutes would be sufficient to have this little machine here. But this is nothing compared to the data that is processed by Google every day. It's 20,000 terabytes of data processed each day. That's 20 petabytes each day. So it's astronomical what we produce as data here every day. Or actually, I should not say astronomical, it's even genomical if you compare where the real big data sources are today, or in the future at least. If you look at projections of data that is produced in 2025, then this little dot there is our enormously grown Twitter amount of data, or amount of Twitter data. This little spot there in the middle. And then we have a little bit more of astronomy data, so data that is collected by looking into the sky, searching for extraterrestrial life, looking at supernovae happening or not happening today, but years in the past. Sort of the same amount of data is prognosed to be uploaded to YouTube each year. But if you look at just the sheer amount of genomics information, it's it's not even comparable to everything else that we are producing here. So we producing, collecting enormous amount of data, and the question is, what should we do with it? Well, to be honest, we should be a bit more rigid in our terminology here. This is just data. So data is symbols, signals, bits, bytes, words, numbers, tokens. Data can be information if used and interpreted in a certain context. So you could see this stuff as just a bunch of letters, or you could also understand that this is obviously a gene sequence with the base information where each base is abbreviated by such a letter T, A, C, and G. Or you could try to use that information and derive some actionable knowledge, to derive something that you can do prediction, that you can base predictions on, or that you can understand something about nature, or that you can control processes with. So with information alone, you haven't gained much. You would like to make this information actionable, and then it becomes knowledge. And the challenges, given our aim to produce knowledge that you can do something with, and the sheer amount of data, well, are a lot of related to IT technology. And here a few of these huge changes that we face, partially they are solved in industry, partially they are a matter of research, and that's partially what we are interested in our big data initiative. So when it comes to data, we have to manage somehow the velocity and the volume and the variety at which data comes at us. We have to make sure that we scale with our processing performance and that we keep the energy level of this processing as low as possible. So energy is actually as important to keep an eye on as performance is. If you look at the information side, we would like to analyze, aggregate, interpret the data. We would add security and privacy components. We would like to handle data quality. What do we do with outliers? What do we do with questions of representativeness of the data? Is what we see here really representative for the underlying processes and so on? And all these questions are summarized under the notion of veracity. Also an issue, and that's actually bridging over to non-IT question is, well, the experts in the domains are usually not programmers. How would a biologist access that information? How would a guy from sociology access the information? Of course, we could do this programming, extract the data from the stream sources, from the databases, but we are not domain experts, and the other guys don't have the programming capabilities, program abilities to do that. So what we observe is that a lot of these classical disciplines, like sociology or even biology or physics, are taken over more and more by programmers. And the guys in these other disciplines, they say, well, give me back my subject. I'm the expert here. I know more about society than you ever would be able to know, because I've studied this. I've been doing research on that for decades. And now you guys, you come over and try to analyze the data just because you can. You can program, right? We have a challenge here. between the different disciplines. Well, at the end of the day, I said we would like to gain knowledge, and that's then about, well, how accurate is that knowledge? How can we interact between new human ways of understanding and gaining knowledge and artificial ways of gaining knowledge? How can machine learning, visual analytics, and human deduction be combined in order to gain even more? Well, these are all questions of our big data, of course, initiative at LNU. We do here applied research and applied sciences. Here are a number of examples from industry and societies that we have learned more about at our workshop in last December. So these are real cases from the region where companies work with big data applications or big data questions together with us. On the other hand, we have some science questions, and I will just pick 3 examples here from that side to explain what our researchers are doing here. So what if we could actually gain actionable knowledge from all the European health registers? So there's an enormous amount of data regarding your health and your well, diseases and possible blood tests and visits at doctors collected each year. It's anonymized, so usually we don't need to fear here any privacy issues. But now we have that, and we have it in each country. And even in Sweden, we have hundreds of those registers for different purposes. So how would we actually get all this information and analyze that information? Well, e-health is one of the research fields that we are dealing with, and they're asking exactly these questions. They try to find out if there aren't ways to actually connect all these databases, all these registers, to do statistical analyses, machine learning analysis, non-classical analyses, visualize information, provide information to experts both in health politics and also in medicine, to actually make politics and political decisions based on real facts and not just on opinions, have some clear key performance indicators of how we would like to develop society, how would we work with health issues in the societies, and even involve people and people's feedbacks and people's ideas in that process. So we have here enormous amounts of data. They are very heterogeneous. We have privacy issues, we have legal issues, we have data processing issues, we have understanding issues, and all this together makes it a very interesting research field for our researchers, and at the same time, of course, this is of high value for society if we succeed. Another field concerns biology. So what if we, for instance, or medicine as well actually, what if we, for instance, could analyze and scan the entire genome of a newborn in just a few hours or a few minutes, if we see, well, there's some severe problem here, right? We see, okay, a newborn baby, or a doctor sees a newborn baby has some severe issues. We have to exclude all possible conditions here, and we would like to do that as quickly as possible. Today we are in the range of a few days, so I think the world record is, so to say, today with the high-end technology at 26 hours. But what if we can do that in hours or minutes? Well, that would, of course, require clever algorithms for matching these genome sequences against some patterns, but also it would require clever ways of parallelizing the processing of these algorithms, so that several thousand processing units can actually do these analyses in parallel, and thereby reducing the analysis time. We have already today gained a speed up of a factor of 10 compared to baseline analyses on a regular PC environment, but we want to get better here. Another interesting question is what if we could actually analyze what people in Sweden talk about in public? Right? What do the people? What's in the mind of the people here? What's so to say interesting for the Swedish people today? So we would like to explore the relationship between what is spoken or what is mentioned or written, and what is in their mind, what matters to them. In a way, we would like to use this enormous amount of social media data that is coming at us, sometimes appreciated and sometimes not that much. Can't we use that as a window to the world, which produces online insights, real-time insights into what's in the minds of the people here? And of course, we mentioned the enormous amount of data that is produced by these social media applications. We will not be able to do that by just having a few interested researchers reading the streams. So we would need, again, to combine automated processing, automated analysis of language and of meaning of language, which is extremely tricky even today, with some visualizations which show some insights, and also with some human experts. Well, these are just 3 examples out of the many interesting research questions with both competence at our university and at the same time interest in society. We would like to build a Linnéus Competence Center, which builds on foundations which are rather mathematical, then on technology, which are most in IT, and then a great variety of applications in industry, society, and sciences, which can be actually added upon demand. We have come a good way already. There are some seed fundings which we have received, enabling all these activities. Most of the people in this room are actually active in this activity today, so I don't need to explain more. If you want to know more what our journey is about today, please contact me after my talk, and then I'm actually ready with what I want to tell you today, and I'm happy to receive some questions here.
Thank you very much. Tack så mycket, Welf. Vad mer att säga? Det är lite banbrytande det som händer just nu, kan man säga.